Welcome to the Energy Sandwich Project. We are from Group 321, Team 3, and this is our STEM.
The objective chose to work on this STEM project was the affordable and clean energy. The main problem is the lack of sustainability in other non-renewable sources of energy. With this, we mean that it produces greenhouse gases, it can damage the environment, the rising costs, and the products are a potential threat to human health.
So, the energy sandwich is a contraption designed to transform and reuse the energy utilized when we water. This transformation is achieved by the main mechanism of the energy sandwich, which is composed of a total of 12 piezoelectric units. These produce electrical energy when they are bent.
All the piezoelectric units are connected to each other, so that the energy generated by any one of the units reaches the one at the end of the chain. The end of the chain of the piezo units is connected to a light bulb, which will be powered by the mechanism. All the piezo units are placed on top of plastic bottle caps, which have had their sensors hollowed out to allow the piezo units to bend. The main mechanism is placed in between two wooden plates, which are covered with foaming. The upper plate has 12 dowels attached to it, one per piezo unit. These are placed in order for them to better apply pressure to the piezo units, which will allow them to bend more easily and create a bigger voltage.
In the project, we will also be using diodes and resistors if they turn out to be necessary for the proper functioning of the contraption. The diodes will be used to redirect the current flow to the light source. This will help to maintain a steady flow current as opposed to the spikes generated by the piezo units. In other words, it will transform the alternate current into direct current. The resistors could be used to regulate the amount of voltage that is allowed to pass into the light source. This is necessary to prevent the light source from burning. However, if the contraption does not generate an excessive amount of voltage, this part of the mechanism wouldn't be necessary and will be excluded from the final design.
Crystals are held together by bonds called unit cells. The unit cells found in the vast majority of crystals are symmetrical. However, the unit cells of quartz crystals, which are used in piezoelectric materials, are not symmetrical. This asymmetry allows for the generation of a small voltage in a quartz crystal's molecules when it is compressed. The way we compress the molecule is by exerting mechanical pressure on the crystal. This crystal is then placed between two metal plates and after it's connected to copper wires. Some examples of where piezoelectricity is used are an electric stethoscope, quartz watches, speakers, and microphones.
So the device isn't finished yet. We have only installed 4 piezos and we're planning to install more for the finished one. Also, we are using an LED and the finished one we're planning on adding a bigger source of light. The independent variable is the amount of piezo units that are used in the contraption, and the dependent variable is the amount of voltage generated by the mechanism to turn on a light source.
Since the voltage output of the contraption is directly proportional to the number of piezo units, if we increase the number of piezo units, then we'll create a greater voltage output with the same amount of weight applied to the contraption.